Good afternoon to all. We are from group 21A-9 that want to present about data 3, that is baseball. Those are my group members' name.
Hi everyone, my name is Sitaisa binti Muhammad Zakaria. I will talk about the introduction. According to the data given, we got 13 different data from baseball players. Our group members use a few methods to analyze data, which are name, systematic literature review (SLR), multiple linear regression (MLR), statistical package for the social science (SPSS), and Microsoft Excel. This data is about how the independent variable X are used to model the dependent variable Y. All these independent variable, which is batting average of Major League Baseball players, was obtained.
I'm Tanjoy from 21A. As you can see on the screen, this presentation is focused on simple linear regression analysis. First is the scatter plot. When the points in the graph are rising, moving from left to right, then the scatter plot shows a positive correlation. It means the values of one variable are increasing with respect to another. This scatter plot shows us high positive. Second is correlation coefficient. From the output shows that the correlation coefficient is 0.824. Third is general form of SLR equation. For the format is y equal beta 0 plus beta 1x. For the dependent variable is batting average and the independent variable is run score. So y equal 0.150 plus 0.865x. Now, the next one is testing the regression slope B1. To test the hypothesis f equal 0.058.001f. Test statistic f is 91.212. To find p-value, the p-value is 0.000, assume a as 0.05. So to conclude, the slope is statistically significant. The last one is coefficient on determination. The value of the coefficient to determine is 0.680, and interpretation of R2 is 0.680. So 68% of the model is a good fit.
Okay, now I will continue the presentation with my part, that is multiple linear regression analysis. For this MLR analysis, there are a lot of independent data that are accurate, that make the data not correct because there is too much accurate from different variable data that causes overfitting. Therefore, these data are not suitable for MLR analysis. Other than that, in the multi-collinearity measurement data, the table shows that the data has no multi-collinearity because the value x1, x2, x3, x4, and x5 are not more than 10, so there is no multi-collinearity in this data. This is also a reason why MLR are not suitable for this data number. Okay, for the model comparison, as you can see in the table show the difference in data between SLR model and MLR model. For SLR model, the distance between the value R square with the standard error of estimate is closer than MLR distance. With the comparison just now, the best fitted model should be the SLR model because MLR model are overfitted and will mislead the result. Okay, for the point prediction, as you can see on the slide, the table shows the point prediction using simple linear regression because it is the best fitted model for the data given. For the hypothesis testing, the result is the null hypothesis is equal or smaller than 0.85. And for the alternative hypothesis, the value is bigger than 0.85. That's all for my part. Thank you.
The advantage of MLR is this strategy might give a result that is more accurate and precise knowledge of the relationship between each individual factor influencing the result. It also reveals the relationship between the different predictive variables itself as well as the links between of the factors and the outcome as a whole.
The disadvantages of multiple linear regression is that the data must be independent. The scores of one subject have nothing to do with the other. For example, clustering in space the students' scores. The students form various classes, grades, and schools. Students in the same class tend to be similar in many ways, such as they often come from the same neighborhood and they have the same teacher teaching them. So they are not independent. Subsequently, MLR is also sensitive to outliers. Outliers of the dataset are anomalized or extreme values that divide from the other data points of the distribution. Data outliers can damage the performance of the machine learning model drastically and also can often lead to models with low accuracy. Outliers can have a very big impact on linear regression's performance. Means they must be dealt with appropriately before linear regression is applied to the dataset.
In conclusion, while the results of linear regressions may appear spectacular on datasets with linear separations, it is not advanced for the majority of real-world applications since it oversimplifies the data by assuming a linear relationship.